The James Webb Telescope shows us the wonders of the universe in unprecedented detail. As the most powerful space telescope ever built, Webb is up to 100 times more accurate than its predecessor, Hubble, and can even easily see into the deepest secrets of those structures that seemed completely invisible to the instruments of the past. And while the $10 billion device has already uncovered one or two cosmic mysteries, it also reveals the overwhelming beauty of the universe in the same breath. From grinning galaxies to a cosmic question mark and an unmanageable army of stars, prepare to marvel at the formations of the cosmos in razor-sharp splendor that will leave you absolutely speechless. Smoking is unhealthy, and yet space explorers can't help but reach for a cigar regularly. Fortunately, however, this particular cigar star does not emit any foul-smelling smoke, but intense waves of star formation, which have now been thoroughly examined by the James Webb Telescope. Also known as the Cigar Galaxy due to its peculiar shape, Messier 82 is famous for its fascinating starbursts. Basically, this refers to phases of rapid and efficient star formation. But unfortunately, most starburst galaxies are so far away from us that studying them in detail is challenging, to say the least. However, at a distance of 12 million light-years, Messier 82 is a welcome exception. And although the spiral galaxy in the Ursa Major constellation appears comparatively compact, it's a prolific star maker. In fact, 10 times more new stars are born here each year than in the Milky Way. However, past observations were often hampered by the dense veils of dust and gas that naturally occur here. Webb's infrared view, however, is now able to break these blinders, and with the help of its NIR cam, even capture images of the actual starburst center. And while the dark brown dust veins permeate the glowing white core of Messier 82, even in this infrared image, Webb presents us with the structure in an unprecedented level of detail. Despite this, for example, we can see small red spots in the center where young stars make molecular hydrogen glow. The green regions, on the other hand, represent the other end of the stellar flagpole. Most of these concentrated iron-rich areas are nothing more than supernova remnants. The first brown dwarfs outside the Milky Way. Is it a star? Is it a gas planet? No, it's a brown dwarf. In simple terms, these objects can be described as a kind of intermediate stage between the former and the latter. Typically, brown dwarfs weigh between 13 and 75 times the mass of Jupiter. On the one hand, they are too low mass to ignite hydrogen fusion inside them, and on the other hand, they are heavy enough for deuterium fusion to begin. Surprisingly, however, these peculiar celestial bodies can sometimes float freely through space without being gravitationally bound to a host star like a planet. At the same time, brown dwarfs also share some characteristics with exoplanets, such as storm patterns or atmospheric compositions. And while Hubble has already shown us that the emission nebula NGC 602 is home to a series of young, low-mass stars, Webb SharpGaze has even found the first candidates for brown dwarfs outside our home galaxy. In detail, the Small Magellanic Cloud is about 196,000 light-years away from Earth. In the image, we see the open star cluster in a colorful nebula of gas and dust. In and around the gas nebula, however, numerous distant galaxies also catch our eye, as do some stars that are much closer to us and give the snapshot a sparkling glow, the luminous splendor of the cosmos. And speaking of sparkling splendor, compared to the image that Webb captured of Westerlund 1, the structures of NGC 602 almost look like puny fireflies. Located in the constellation Era and discovered in 1961 by the Swedish astronomer Bengt Westerlund, it's nothing less than the most massive open star cluster known in the local group. A brief explanation. Experts refer to a collection of galaxies, including our Milky Way, as the local group. Expressed in numbers, the exuberant star wealth of Westerlund 1 means that 50,000 to 100,000 solar masses are found in a region whose diameter is not even 6 light-years. A tremendous stellar population, but one that is also associated with explosive consequences. In fact, experts estimate that more than 1,500 supernovae will occur here in less than 40 million years. At the same time, Westerlund 1 serves as a natural laboratory for scientists to study extreme stellar physics. Here, They can understand how the most massive stars in our galaxy live and die, and how stellar winds, supernovae, and other ejected material influence star formation in the surrounding area. The dance of the galaxies. It almost looks as if the two galaxies of ARP-107 could not be happier about their fate. In detail, we are dealing here with two interacting galaxies in the constellation Leo Minor, a good 440 million light-years from Earth. While the larger spiral and smaller elliptical galaxies are about to merge as a result of their cosmic dance, the orange and red star-forming regions, made of gas and dust together, form a kind of smiley face. And yet, grinning structures are not the only thing that Webb has brought to light here. Thanks to the mid-infrared instrument, or MIRI for short, we now also know that an almost transparent white bridge of stars is hidden here, which was torn out of both galaxies. The bottom line, however, is that in several 100 million years, the two galactic partners will have merged to form a significantly larger, irregularly shaped galaxy. The edge of the Milky Way. The Earth is about 26,000 light-years from the center of our home galaxy, but the so-called Dealey Clouds 1 and 2 are separated from the heart of the Milky Way by a distance of 58,000 light-years. So, they are located in a region that experts call the extreme outer galaxy. A team of experts used Webb's NIRCam to take a closer look at certain areas of the two molecular clouds, revealing completely new aspects of these remote regions, which hide star clusters along with stellar nurseries. Although the two clouds are part of our galactic home, they are relatively poor in elements heavier than hydrogen and helium. As a result of this composition, they are more reminiscent of dwarf galaxies or the young Milky Way. And while Webb confirmed the previously suspected existence of a subcluster in one part of the image, we also see weak jets extending in different directions from the bright structure. The cosmic question mark. Many astronomical structures are accompanied by a giant question mark, and another one literally, as we can see in the next picture. The corresponding punctuation mark also seems to have a permanent place in the cosmos. In fact, ESA emphasized that the image is by no means a fake or a hoax, but a pair of actively forming young stars, scientifically designated Herbig-Haro 46 of 47. Although the snapshot has the potential to become a meme, astronomers, unlike the internet, are not making a big deal out of the question mark formation. Their main focus is on observing star formation, a glimpse into the planetary nursery. What is perhaps only a reflection nebula in the constellation of Perseus, by definition, is also another remarkable example of the elemental processes that take place in the depths of space. Located about 1,000 light-years from Earth, the structure NGC 1333 is a gigantic star-forming region that is home to countless stellar babies younger than 1 million years. The mass of this region is estimated at about 450 solar masses, but that's not all. Webb's sharp infrared view also penetrates the dusty veils in this case. We also see gas and dust disks in the picture from which new planetary systems may emerge. The hidden intricacies of Messier 106. In an astronomical context, Messier 106 is only a stone's throw away from us. Even if the cosmic house cat would still have to cover a distance of 23 million light-years. As one of the closest and brightest barred spiral galaxies in our vicinity, this galaxy also has a central supermassive black hole. But intriguingly, this one appears to be particularly active. Compared to the mass monster at the heart of the Milky Way, it devours significantly more material. While the bizarre beast actively devours dust and gas, Messier 106 also has another remarkable feature. It has two additional anomalous arms that are only visible in the radio and X-ray range, not in the visible range. This is because these arms are not made up of stars at all, but of hot gas. Astronomers suspect that their existence is due to some kind of feedback effect from the black hole. In detail, they are probably formed by outflowing material, which is created by the violent circulation of the gas around the gravity monster, and thus sets a process in motion that can be compared to a wave hitting a rock near the shore. The cosmic jewel ring. Where the gravitational lensing effect meets a distant quasar, the end result is a picture reminiscent of a ring set with jewels. In simple terms, gravitational lensing causes the light rays of distant sources to be influenced by objects that appear to lie in front of them. In this context, the structures behind them could be optically enlarged, distorted, or, as in this case, multiplied. In detail, we see here with RxJ 1131-1231 an active galactic nucleus 6 billion light-years away, which is influenced by the strong gravitational field of an elliptical galaxy in front of it. The galactic gravitational lens presents itself as a small blue dot in the center of the ring, while the orange glowing gems show one and the same quasar in multiple versions. For scientists, however, the gravitational lensing effect is much more than just an optical gimmick. After all, it occasionally makes objects visible that would otherwise be much too far away or too faint to be studied in detail without this natural effect. And if you now search below our video, you will quickly discover the like and subscribe button. We would love for you to join our community so that you can stay up to date. From now on, we'll see you soon on our channel Digital Discoveries.